So welcome to another segment as we try to look at chemistry question. This is under organic chemistry. So it says the following diagram shows some of the reactions of ethanol. So these are reactions of ethanol. So you can see the flow, the flow chart that you have. Ethanol undergoes oxidation to produce solution P. Then ethanol undergoes complete combustion to produce gas R and also water. Then ethanol undergoes process Q to produce ethene. That's what they're telling us. Then A there, it simply says draw the structural formula for ethane. So they want us to draw the structural formula for ethane. Now I want you to remember that the general formula of this homologous series, the alkanes, is simply Cn then H2n plus 2. And when you look at eth, simply means the number of carbon are 2, meaning when n is equal to 2. So you can write the molecular formula. It will be C2. It will be n is 2, so 2 times 2 is 4 plus 2. That will give you a 6. So this is the molecular formula for ethane. So we can draw the structural formula. In this case, there are how many carbon? There are only 2. So you write with the 2 carbon. And remember, these are simply saturated. They have got a single bond between the carbon atoms. Now, each carbon needs to have 3 bonds for it to be stable. So this one has 1, so 3 are missing. 1, 2, 3. Even this one has 1, so 3 are missing. 1, 2, 3. Then you attach the hydrogen. There are 6. 1, 2, 3, 4, 5, 6. So this is the structural formula for ethane that they wanted us to name. Hopefully we are together. Please, you can still watch out some more videos on organic chemistry and actually get to learn. Yeah, I'll produce some more. So it says give the names for the solution P. So when ethanol is oxidized, when ethanol is actually oxidized, it actually changes into what we call when alcohols are oxidized, they change into carboxylic acid. But because we're using ethanol, so the name of solution P is simply going to be, ethanoic. So that is ethanoic acid. So that's what you need to remember when it becomes oxidized. Then process Q, ethanol becomes ethene. Now if you notice there's E here, ethene. So what process converts ethanol into ethane? This is what we call as being a dehydration reaction. So it is dehydration. So when water is actually eliminated from the alcohol, what is actually going to be produced is ethane. So that's a dehydration reaction. Then what about gas R? When ethanol undergoes complete combustion, or complete combustion produces, the gas is simply carbon dioxide and water. That's complete combustion. So the gas is simply carbon dioxide. So that's what you needed to remember. And this is what you needed to do there. So if you want just to write them, properly, so that is going to be those reactions. Then the C part, it says write a balanced chemical equation for the complete combustion of ethanol. So they want you to write a balanced chemical equation for the complete combustion of ethanol. So a balanced chemical equation in this case, ethanol has the formula C2H5 then OH. So complete combustion means that it burns in excess oxygen. So when it burns in excess oxygen, it produces carbon dioxide and H2O. So that is what is going to be produced. Now, of course, they want us to write a balanced chemical equation. So if you notice 5 plus 1, the hydrogens are 6. You can put up a 3 there, such that 3 times 2, that will give you also a 6. Then carbons are 2, so you can put up a 2 there. It means the carbons will be 2. Now look at the oxygen. This side here, there are 4 plus 3. That actually becomes 7. So what you can do is that you can put up a 3. 3 times 2, that is 6, plus this one oxygen there, that is 7. Otherwise, this is a balanced chemical equation. If the wanted state symbols, ethanol is in liquid form, oxygen is in gaseous form, that is going to be in gaseous form, and that is also going to be in gaseous form. But at a later point, it may actually condense into a liquid. So you may find someone saying that is going to be in liquid form. Thank you so much for watching. Watch out for some more segments of organic chemistry later on.